All right, so the first one says the graph shows the amount of money Ava saved over several weeks. We have find and interpret the slope. We aren't going to discuss the unit rate at all because in this case, the slope and the unit rate are always going to be the same answer. So there are a couple different ways to find slope. Since we're about to do a lesson entirely with the slope formula, I'm just going to show the one way for graphing right now, and that is to count your rise over run. So your change of y over change of x is your rise over run. And if you're rising or going up, that's going to be a positive change in y. If you're going down, it's going to be a negative change in y. If you're going to the right, that's going to be a positive change in y. And if you're going to the left, that's going to be a negative change. Oh, sorry, I meant to say x there, not y. A negative change in x. And when we do our rise over run, we do have to be careful of the units. So I see here that it's changing by fives. So when I do that, I have to make sure that I'm counting fives and not 1, 2, 3. So here I rise 5, 10, 15. So I can write rise 15. And then I run to the right 1 because these are changing by ones. So I write right 1. And this is a positive and this is a positive. So we get that our rise over run is then 15 over 1 or 15. Next, we have the graph shows the distance William walked for various hours. We're going to do our change of y over change of x again. Here's our rise over run. So we're going to count. We rise 1, 2, 3. And we go to the right 1. Rising is positive, right is positive. So we get 3 over 1, or 3 for our slope. Next, we have a grocery store is having a sale on oranges. The cost y in dollars of the oranges and the number of oranges x are in a proportional linear relationship. This situation can be represented by y equals 1/3 x. So we are going to switch the order of this. We're going to go first this and then this. So a proportional relationship is an equation in the form y equals kx, with k as your slope, and it passes through zero, 0. So in this case, if we have y equals kx, and then our equation is y equals 1/3 x, k is then equal to 1/3, which is our slope. So to graph this, we'll start by plotting 0, 0. And then we have to look into our slope, which is our rise over run. So we're going to rise 1 and run 3. So we rise 1, run 3, rise 1, run 3, rise 1, and run 3. And then we are going to connect those in a straight line. We're actually going to do a ray because in this case, this situation tells us that we can't go into negative x or y's because we're talking about oranges and money. And then our last one says the distance y in miles that a certain cyclist can ride and the time x in hours are in a proportional relationship. This can be represented by the equation, and we're going to change this because that's way too big. So we're going to make it y equals 4x. And then again, we're going to do the opposite. We're going to discuss the slope and then graph the equation. So again, a proportional relationship is y equals kx. If we have y equals 4x, then k is equal to 4, which is our slope. And we know slope is rise over run. And in this case, we can rewrite 4 to be 4 over 1, so it looks like a fraction. So we're going to rise 4 and we're going to run 1. Like always, we start with 0, 0. Then we're going to go rise 4, 1, 2, 3, 4, and run 1. Rise 4 and run 1. And again, we're going to do array in this case. We're not going to go into the negatives because we are talking about distance and hours, which cannot go negative. So that was 4.1 notes, a little bit on proportional relationships and a little bit on graphing.